Well, welcome everyone to today's webinar, The Future of Vision Zero. This is part of ConnectMe's Agentic AI and Traffic Engineering webinar series, and we are delighted to have all of you in attendance today. I'm Pete Croswell, president of Croswell Schulte IT Consultants, and also an adjunct instructor with Penn State University. I'll be moderating this event and hosting the Q&A session at the end. I have over 40 years experience as a government employee and consultant in GIS and various IT domains, including transportation planning, ITS, and infrastructure asset management. I'm a past president of EURISA, now the Geospatial Professional Network, and I'm pretty active in various research and educational opportunities. In my career, I've had some exposure to Vision Zero initiatives, but like many of you, I'm looking forward to learning more about it in today's webinar. I'm guessing that most of you are familiar with Vision Zero, but you may not be aware that it started in Sweden and became a national policy there in 1997. Vision Zero is often characterized by the safe system framework, which is all about practices in roadway infrastructure to optimize safety and reduce accidents, pedestrians, cyclists, motor vehicles. And as we all know, there's a heavy focus on reducing major injuries and death. As we will learn about today, Vision Zero programs have a heavy reliance on data analysis, and data visualization. Many local governments and state and provincial transportation agencies have long used geospatial data analysis applications to better understand their crash data from a map-based perspective. But conventional approaches have been limited by unavailability of detailed data and just lack of tools and skill sets to conduct detailed analysis of that data to answer questions about traffic and accident and pedestrian safety. The agenda today includes presentations by 3 speakers who I'll introduce here shortly. But before we get started, we'd like to run a quick poll of the audience just to learn a little bit about where you're from and your organizations. So you can see that poll pop up. Please take a few moments now to enter your responses and then hit submit. And as you're responding to the poll, I'll go through a few housekeeping items. First of all, in addition to hearing from the panelists today, a really important objective is to get your active participation. And you can do this by entering a question or a comment in the Q&A space. Please be aware that the chat box is disabled and also microphones are disabled for the webinar. But please put a question or comment at any time during the webinar in that Q&A space, and we'll handle those in the Q&A session at the end. For information about speakers and for the event agenda, you can see the resources tab at the bottom of your screen. You can click on that. And also there's a tab in there that's got a number of useful links that you might consult later. The session is being recorded, and after the close of the webinar, you'll receive an email indicating when that recording is available. We'd very much like to thank our webinar series sponsor, MyoVision, for making this educational opportunity available to you. So just before we get going, let's take a look at those poll results. Okay, your organization type. So not unexpected, we have a large number of local government, 55%, also a good bit of state government, academia and private industry represented as well. Where are you from? Large participation from the USA, some from Canada and Europe. So welcome to all of you. Business sector. Land public administration at 13%, transportation, that's probably state provincial level, most of that at 25%, and public works utilities, 50%. And then finally, municipality by population, small amount under 25,000, 25 to 50,000, 13%. got a good participation of over 100,000. Good. So again, we're happy to have you. Thanks for that information. Today's featured presenters come from the private and public sectors, and each of these speakers has in-depth education and experience in traffic and transportation engineering, safety, and data analysis and visualization. First speaker today is Craig Milligan. He's a road safety engineer with Fireseeds North. Craig earned his PhD in civil engineering from the University of Manitoba with a focus on road safety performance forecasting. He is active in research on road safety topics and has worked with more than 120 road agencies in 4 continents, providing expert support in road safety. Brent Rogerson, our next speaker, is the Director of Solutions Engineering at MyoVision. He has about 20 years of experience in local government and the private sector in a variety of technical and customer support roles. At MyoVision, he leads the team that transforms transportation data tools into real-world intelligent transportation management systems. And finally, we have Chris Ryder. He's with the LA City Department of Transportation. He's got over 22 years of experience in transportation industry. Has a deep background in computer science, focusing on data-driven strategies to enhance safety and efficiency for all roadway users. I want to stress that this webinar is educational in purpose. And while there is interest in making you aware of products and services by MyoVision and Fireseeds North, the focus will be on conveying concepts, best practices, and tools available to support Vision Zero initiatives. So again, thanks for your attendance today. Let's get started. Craig, over to you.
Hey, thanks a lot, Pete. Like I said, my name's Craig Milligan. It's a real pleasure to be here with you guys today, talking about the future of Vision Zero mapping. And like you said, I work for Fireseeds North Infrastructure. I'm a consulting road safety engineer. I have built hundreds of road safety maps, crash data maps, all kinds of maps to answer all kinds of road safety questions. It's a key component of what we do as road safety engineers, and we also rely on colleagues in GIS departments to help us with the mapping often. So it's a place where GIS folks and traffic and transportation engineering folks get together is around the map to say, what can the map tell us about where our problems are, where there are trends developing, what kinds of things we need to take care of. So when I heard about a chance to do a webinar related to Vision Zero mapping, I got really excited about it. And a little bit more about my background. In addition to working as a consulting engineer, I got a little bit into technology development. And I was kind of tired of using crash data for some reasons I'm going to elaborate in my presentation. And I wanted a technology that could tell me about crashes before they happen. And I ended up developing near-miss video analytics technology that could detect near misses at intersections. And I'm going to be telling you a lot about that. MyoVision was gracious enough to kind of take over that technology and really take it to the next level. And so they kind of became the hosts of this technology. And I went to work for them a little bit before going back to consulting engineering, where now I'm an enthusiastic user of this technology among my other consulting road safety engineering projects. So sometimes I'll be saying we as if like, MyoVision and I did this together. Like we really did collaborate on this. And I'm going to tell you about some of the tools we built. I'm going to be talking mostly about new data that can go onto maps instead of the old crash maps with just crash data, the new types of data and why it's a bit revolutionary. Brent is going to talk about new ways for interacting with maps. When I started making maps, I found GIS-based queries hard. I'm not a GIS specialist. I can understand, I can build a query, I can make different types of maps, heat maps, buffer zones, all that kind of stuff, but it's slow. For me, it's slow. And Brent is going to be talking about ways where you can just unlock speed and creativity and data fusion and connection through AI and agentic AI. I'm not going to be talking so much about that, but more so about the new data that you can call on and bring to surface in a map. He'll be talking about new mapping technologies, and then Chris will talk about what it means in the public sector. So that's kind of an orientation to the webinar. Um, Maybe a little bit about why I chose to kind of hand over my near miss technology to Myovision is because of the power of their intelligent mobility platform. It's in a huge amount of deployments in 68 countries. You can see the density on the map here. And the platform, why it's so powerful is there's like a 360-degree camera over the intersection, and then there's a high-powered computer sitting in the traffic control cabinet. Computer vision runs to get a awareness of everything going on and all the movements at the intersection. And then that becomes the foundation for a whole bunch of applications that serve to measure and optimize and improve traffic. So there's things like emergency and conditional priority, transit priority detection to actuate green lights when someone is there waiting, give them the green light, V2X, and safety is the stuff that I brought into Myovision, basically detecting near misses and reacting to those near misses. Sometimes with a warning out to road users through V2X, and sometimes it's just measuring, harvesting that data back and making it available to mapping applications. So I'm going to be talking really about the near miss data, and it's the technology I developed, and why we put it in Myovision was because of this platform and these 360-degree cameras and the computers that go in the traffic control cabinets. They're spreading from intersection to intersection and city to city. It's on a rapid growth trajectory because it's a very powerful platform, and that's why I wanted the safety tagged onto that. So the bulk of my presentation, I'm going to talk to you about this new data source, and I characterize it with three adjectives. This new data is predictive. The new data is continuous, and the new data is high resolution. And I'm going to talk about each of these in sequence. And it's enabled through continuous safety monitoring. This is the application that runs on that camera and computer system at intersections. That's the name of the app that is measuring the near misses continuously, continuous safety monitoring. Why are we going in this direction? Why do we need a new data source that was predictive, that was continuous, that was high resolution? We have tons of crash data, right? Well, I want you to think about something. We have 42,000 people dying each year from traffic crashes in Canada and the US, many more globally, up to 1 million globally. And we keep pouring money into road safety. And if you look at the national level stats year after year, we're barely making progress some years, and other years it goes in the wrong direction. And something about the way we're trying to improve safety, the methods, the data sources has to change. If we keep putting money, dumping money into this, the same things, the same data sources, we're going to keep getting the same results. And it's safe to say that the current approach to road safety is not working. There are some great initiatives, some great gains in pockets and localized areas, but on a national level, it's not working, and we need to try new things. And my thought after working at hundreds of intersections was the data that we're using to drive all of our decisions has some fundamental flaws that limit how effective we can be. And those flaws are that the data that we use, it's reactive, it's inagile, and it's low resolution. And each of these flaws matches to one of the improvements that we introduced with near miss data. When we use crash data, we're taking action after an injury or death. But near misses, we've proven and written in scientific research articles about this, peer reviewed with university partners. When you measure near misses, you can predict the number of injury crashes coming in the next 5 years with 94% accuracy. As long as you measure them the right way, which is with a kinetic energy-based risk rating. It's inagile, and what that means is like agility is how fast you can make changes, pivot, change again, get the feedback on how you're doing, and change again, and just keep iterating until you get to the solution you want. Excuse me. But with crash data, it comes in, you need to really wait 2 or 3 or 4 years to see a pattern developing. And so you make a change, you have to wait that long to know if you got a benefit. And that limits the frequency at which you can try interventions in a trial and error based approach. And low resolution just means you have a few data points at each intersection. It's not giving you a deep, deep dive into the root cause of the problem. When we introduced near miss data, we aimed to bring a smarter approach to road safety, measuring with the computer vision trajectories, the speed, the potential impact angle, the temporal separation. All these things combine to make great predictors of crashes that have been scientifically validated. We're looking at different dimensions of risk, like likelihood, exposure, severity, harvesting just tons and tons of data on the intersection. And by doing that, we are have brought forward a new data source that's continuous, proactive, and precise. Um, I'm going to tell you a little bit about the continuous safety monitoring tool and the types of data that it's throwing off at hundreds and thousands of intersections where it's already installed. Um, and then just kind of conclude with a little taste of how safety mapping can be different through this before handing it over to Brent. So we're going to kind of dig in to just let you visually see the types of data that are produced. The tool has kind of three main sets of data. You can look at a conflict overview dashboard, a signal phase dashboard, or a conflict clipped review. And the different dashboards answer different questions that are shown on the screen here and are going to be better illustrated when I dig into each dashboard. And as I'm presenting this stuff, I want you to think what kind of, maybe you're a GIS specialist, maybe you're a traffic engineer, I don't know. But you can think, what could I do if I mapped this data? What kind of questions could I answer? What kind of budgets or programs could I develop and implement if I had maps that could interact with this data in unusual ways? Okay. The best way to show you is a real case. So we're going to look at St. Charles County, Missouri. And you open up the map. These are all the MyoVision installations in this location. Here's the intersection we're going to be looking at, Wentzville Parkway and Great Oaks Boulevard. It's two wide suburban arterials. Here you have a two-way center left turn lane with a protected permissive left turn phasing, fairly heavy traffic, big wide crosswalks, long pedestrian crossing distances. Just not an awful intersection, but an intersection that is going to present some safety risks that are going to depend on traffic flow conditions and user behavior and a number of things. And you don't really know what risks are going to be here until you start measuring them. So I'll show you what we can measure at an intersection like this. When you get into this, and this is the MyoVision 1 platform, all the locations are on a map. Continuous safety monitoring is one of the applications, and you can see here they have installed that app at this one intersection, Wentzville Parkway and Great Oaks Boulevard. The way the system works, it's kind of like every time you put that hardware, the camera and the MyoVision core device, it's like putting a smartphone at that intersection, and then you can push apps to it. So if they pushed at the time when I created this example, they had pushed the safety app to one of their intersections. People try it at 1 or 5 and then eventually push it out to all their intersections. Once you click in on that intersection that has it licensed, you can see conflict overview dashboard, signal phase dashboard, and video conflict clips, and we'll step through each quite quickly. Here's the conflict overview dashboard, and you can use filters to choose what time period. So this is the last 30 days. You can, and then you can look, what are the vehicle conflicts happening? Vehicle bike, vehicle pedestrian. That's the first thing you see. And in vehicle, there's two bars that are really popping out as high frequency conflicts, which is eastbound left versus westbound through, and westbound left versus eastbound through. And if I just jump back to the Google Earth photo, that's people trying to make this left turn across oncoming traffic. You can see how steady that traffic is and the chance of getting T-boned if they don't have a good gap. These are the near misses that we're measuring most frequently in both the eastbound left and westbound left directions. That's not always the case. Like other intersections, different near miss patterns pop. The little video I showed before, you could see a northbound left vehicle and a pedestrian on the west crosswalk, and sometimes that's the spiking one. The colors here denote risk, where green is a low risk conflict, yellow medium, orange high, and red critical, based on the kinetic energy risk threshold. You can see things like the time of day when it happens, the daily trends, and you can filter in for specific conflict configurations. We measured dozens of different conflict configurations. So we talked about that left turn versus oncoming. There's 4 of those at every intersection. The left turn versus a pedestrian. As you exit the intersection, there's 4 of those prototypical ones at every intersection. So maybe the northbound left versus the west crosswalk, not a problem, but the southbound left versus the eastbound crosswalk, that's the one that's popping. So once you do all the permutations and combinations, there's dozens really of conflict configurations. When we have a pair of movements, that's a configuration. And when that pair is repeatedly involved in a conflict, that's when we're detecting a problem and predicting that a crash is going to be coming. You can see how fast the road users are going and how far apart they are in time. And you can use that to diagnose different root causes and different solution strategies. You can see when they're happening during the day. And just to give you an example here, here you see them broadly distributed throughout the day, right? There's mild peaks in the AM and PM peak. If you had one crash at 7 a.m. That someone got seriously hurt, and you started asking some people, and everybody said, yeah, that's hard in the morning rush hour. It's hard to make that left turn. You could end up without any of this data going in and saying, okay, left turns are restricted at this intersection every morning from 7 to 9 a.m. That's a common road safety treatment. But without this data in place, you wouldn't recognize that 80% of the problem is going to be untouched outside of that 7 to 9 a.m. window, because this is a problem that's broadly distributed throughout the day with mild peaking. If we had a very sharp AM peak and almost no issues during the other hours of the day, that would be an interesting and appropriate solution, but it's the wrong choice for this intersection. But if you're just using crash data that's low resolution, that's anecdotal, that's infrequently coming to you, you could end up going the wrong direction in your solution. So even something like the resolution and the detail you get from hourly temporal distribution can really help you. Same thing with signal phase. You can know, is it the left turn that's violating? Is it the through vehicle that's violating? Is that happening during amber or red? Different root problems, different solutions. You can watch the clips, and basically you can get a ton of detail about the nature of the problem. Here, you know where most of the risk is, how you can fix them, and that you need broad time of day based strategies. As I kind of wrap this up before I hand it over to Brent, what I really aim to show you is not the tool itself, but the new data that's now exists. And that new data is predictive. It's near miss data that can predict crashes with 94% accuracy. When you know exactly how many eastbound left versus westbound through crashes of high, medium, critical risk levels, you can actually put that in a formula and say, we will have this many injury crashes in the next 5 years. It's going to be 94% accurate. It's high resolution and detail. You know the movement pairs, the hour of the day, the signal state. You know if it's during the protected or the permissive phase, late in the permissive phase, near the signal change, which crosswalk, which direction, everything like that is super detailed, which is really often missing from crash reports. And it's continuous. It's fresh data every day that unlocks agility, because you could make a change at this intersection, and then check the next week to see if the near misses went down. So the continuity of the data stream allows you to kind of experiment on this intersection and innovate on it until you unlock the solutions that drive the near misses down. And if you drive the near misses down, because of the predictive nature of it, you will be driving the crashes down in the next 5 years. So I just give you some example of how this could work with maps. Instead of creating one set of safety maps that kind of guides your work for a 5-year period, you can create new maps any day. And I'd just like you to think of this idea like a bad event happens. Someone dies in a left turn pedestrian crash on Thursday night in the middle of the night. On Friday morning, City Council wants to know where else do we have a problem with this nighttime left turn pedestrian crashes. It's in the news. They want to spend money on lighting and other fixes. They're saying they want answers and they want them on maps. And at 9:30 a.m., you send them a map, this exact issue, not other issues, not where we have lots of crashes, not where we have an escalating number of near misses between midnight and 6 a.m. of left turn versus pedestrian. This exact topic. Pretty quickly, there's a budget in place. Work starts Monday morning. And think of this, you never put a single geospatial query into the database to make it happen. All you did is ask the system to generate this type of map by telling it the type of map that you wanted. And then the next week, it's a different issue, and you ask for a different type of map, and a new type of map is generated. This idea of interacting with the data in a fluid way, in a language-based way, is what my colleague Brent is going to talk about next. So I've introduced a new data source, and he's going to talk about how you can put it to work on maps. So with that, I'll ask Brent to come on stage and share from his perspective.
Awesome. Thanks, Craig. All right, so let me switch to this. And share. All right. All right, thank you so much, Craig. That was great. Lots of really good information. Lots of really cool stuff that we can do with data and maps as well. So I'm gonna build off of a little bit of what Craig was talking about and show you some of those live in examples, and even show you kind of how AI can really help with the mapping aspect of some of the safety data, but not just the safety data, all the correlating data that goes along with safety data. And I'll expand on that a little bit here through the presentation. So in many ways, as I'm going through this, think about how we can accelerate our safety analysis with AI. So before I get into that, a little bit about myself. My name is Brent Rogerson. I lead our solutions engineering team at MyoVision, and I've been in the industry and at MyoVision for just over almost 18 years now, and dedicating a lot of my life to the production of data or tools to create the data sets that the traffic engineering teams need to actually go and solve very complex engineering challenges. So in many ways, I think about this as building out our intelligent mobility platform. And this comes with the use of AI-based video detection. So Craig talked a little bit about that with the edge compute box that we produce. We integrate a lot of connected vehicle applications to know where vehicles are, especially the larger moving vehicles like fire trucks responding to a fire call, or even freight vehicles moving through the intersections, to allow for enhanced performance-based data set beyond just sensor data. Think probe data, connected vehicle data coupled with the sensor data, and build out this very large system architecture of all the relevant data sets. My background is in what we call geomatics, and so I went to school for geomatics, and that's kind of a combination of computer science, urban behavior, and GIS spatial analysis. So I grew up with maps in a lot of ways, and I grew up alongside traffic engineering teams trying to plot out different development activities and how to build systems alongside of that. So this is a large, this is a very exciting and a large part of my life, and I really love talking about all the cool things that we're now doing with AI to be even better, and move faster, solve problems more holistically, and make sure we're making things better for our communities. So first, we talked a lot about safety data, and Craig was talking about the near miss analysis, but there's a lot of layers to this. And if you're a GIS specialist, I can imagine you're very, verse in tools like ArcGIS and putting layers together. But there's a lot of components to actually understanding what is going on and what information could lead to it or what our countermeasures want to be. So there's two sides of it: is understanding the problem and developing the right countermeasures to the problems. And these take perspectives, these take enhanced information. So traditionally, we look at historical crash data of a particular location or scenario, sometimes hospital records, to what degree are these things related. But as Craig said, it takes 3 to 5 years before a trend actually emerges. And by that point, a lot of incidences have actually happened. Then there's the next layer of just the physical environment itself. Think like roadway design, lane widths, medians, how the right turns are designed, pedestrian and bike assets, like how are the sidewalks designed. There's a lot of geometric data that we need to think about that actually overlaps with even how we're starting to think about systems architecture around connected vehicles and autonomous vehicles. Like all these layers are really important. Then we get into the sensor produced data or the connectivity produced data, like exposure and behavior. So like traffic volumes is a very common one that tells us how many vehicles are on the road that may be impacted by critical near misses that are happening, or speed as a layer to that, just how fast are vehicles going. Often just how the signal designing itself came into play. So like left turn protected, leading pedestrian intervals, and then layering that with the conflict near miss data that Craig was talking about to actually understand the full exposure and the predictive analytics of what is going on before an incident actually occurs. And then lastly, the human context, the neighborhood, the school zone, the transit hubs, the commercial zones. Where exactly are these things occurring and why might they be occurring as well? And so all these data sets are actually um, very interrelated to how you want to develop a countermeasure. And it's important to have that full perspective. Where we're really excited about Craig's developed near miss analysis is we can actually start seeing these things before they start actually occurring, and so that we can start resolving them proactively instead of getting somewhat lost in all of the different data sets layered together. Let's focus on actually solving the problem. With that said, so like let's build towards how AI can actually help us here. So MyVision built out a MyVision 1 platform. Think like a unified data platform or unified data lake where you can put all these different data points into it. You can layer them on the map and you can see them live. You can see what intersections are doing. You can layer on where vehicles are, where are the sensors I have. You can see a video camera there looking at an intersection, and where things may be occurring, but start unifying the data sets so that AI actually has the opportunity to help you compile data sets or help you with different perspectives. So this is the map-based layer, the bottom layer of the mix, where we put in all of the different nodes and different data components connected to the map itself, as in the intersection, the location, the area study. So at an intersection level, you can go even deeper. So Craig talked a lot about the high resolution mapping at where near misses are occurring or where vehicles are actually moving through the intersection. From here, we can see signal phasing and timing, the detector data, the vehicle trajectory and classification that's being layered into there. But this produces a significant amount of data sets. So we have performance-based measures, so how well are vehicles moving through the intersections through some of those traditional ATSPMs or automated traffic signal performance measures. We have the turning movement counts that give us our total volumes, our exposure, our multimodal classification breakdown. It's really important to understand how many pedestrians, how many bikes, how many trucks are actually on the road. We can then understand compliance. Are people crossing the road when they should? Are they running red lights? Are there other pseudo safety challenges going on here where there's a compliance problem leading to potentially the near miss analysis that Craig was talking about? So compliance is very much related to conflicts, as well as clearance. How long is it taking people to actually cross the roads, move through the intersection safely? Are those more vulnerable road users? getting through the intersection safely. And then lastly, even integrating some third-party data sets like probe data or historical context data. So in any case, you have this high resolution visibility of the intersection and then mapped out across an entire network. So with that said, the one thing that I run into a lot over the last 17 plus years in the industry is everyone's been trying really hard to collect data, produce data, to integrate systems. And we are now arrive at this moment where we run into the same challenges. Cities have small teams, they're under-resourced. A lot of these systems are still fragmented, and we need to finish some of the integrations. But a lot of the analysis itself is very manual, looking through that raw data and actually arriving at that insight that you're actually looking to. And this is a very common theme in the capacity that city agencies have to actually solve traffic challenges with that much data now available to them. So for this reason, we created Mateo. Mateo is a Gen AI agent embedded into the unified data model of Myovision 1, where not only are we integrating our data sets, but also any data set that has an API accessible to it. It started as a conversational chat interface of the data, so you can ask basic questions of the data itself, but it's expanded significantly with a tool called AI Studios, and I'm going to show you that in a demo form here in a second. But really what Gen AI really lets us do is to look at these data sets together now, compile the operational analysis, the signal performance, the safety, put all of these things together and help us get to the data set where we can make decisions. Think of this as a super powered co-pilot or assistant to the traffic team that can continue to work for you. It has the knowledge and the smarts of a traditional traffic engineer, but it also doesn't need to sleep or eat or take all the holidays off. So it can continue to work for you and help you actually solve some of these challenges. So let's go further. Let's build on this. So what Mateo actually is I would think about it in three different buckets here. So there's the LLM, there's the ability to think of it as like the book smarts. It's what are the traffic engineering policies? What are the design principles? What are all the aspects and terminology and all the components that your traffic engineer would know because they went through the textbooks and they understand it. So think about the LLM as knowing the base layer of all the traffic engineering concepts. You do have the ability to upload your own principles and your own guardrails that you'd want to put on that based on what you do for your context. But think about it as the knowledge of traffic engineering is the first pillar. The second pillar is context. So think about data, all the API connections, the sensor produced data, the unified data model. So all the things that you want to do analysis on is that context. And then the third bucket is the tools, the skills, the things that Mateo actually knows to help you compile the data, put those APIs together. It's the text, the tables, the maps, the charts. It's all of that putting it together for you in real time. So first, let's start at the bottom here. This is the conversational version of it. So think about just interacting with a large data set of locations on safety data to start. We have that deep analysis chart that Craig was showing, but you can now ask basic questions of the chart itself or of the data set or of the network. So in this example here, it was a very basic scenario. What locations have the highest near miss conflict rates? It's going to go and look through all the intersections and all the data sets over the last 7 days. Obviously, you can give it different timeframes or more specific direction on what you're looking for, and it will compile those data sets very rapidly. And one thing to note is I didn't actually cut this clip. What you're seeing is actually the actual experience in the platform so that it loads just this fast. And so you're actually seeing the real experience of how fast AI can actually help us. But we can continue to dig deep into this conversationally. So what are my top conflict rates? And then break down the top 5 by severity. As Craig was showing, we can look at critical, high, medium, low, all based on speed and encroachment time. And so now we can map that out over severity breakdowns. We can look at conflict types by breakdown as percentages of volume and effectively have summaries of where should we look. The main purpose of this is where do we look? Where do we start? Which intersections are the worst? How do we start normalizing some of the data sets in a way that we can interact with the highest priority issues that are happening whether it's vehicle to vehicle, pedestrian to vehicle, or cyclist to vehicles, and start prioritizing our time and getting ahead of which intersections are the worst instead of waiting for that incident to happen. So you can see just conversationally, I was able to compile the data, put it on a chart, and really start understanding where I should focus my energy and which intersections are having the highest exposure to then go deeper into the charts that Craig was showing you. So that's probably layer number one. I would call that conversational. I'm going to ask some questions of my data sets. The next layer, which gets really fun, is what I call AI studios. This is where we actually can start putting the building blocks together. So in an AI studios, this is where we can turn our canvas into anything that we want. This is where we can build a dashboard. So not only am I asking Matteo here to compile the data sets, and I chose something a little bit more simple for the purposes of this little clip. I've asked it to create a dashboard that visualizes pedestrians' activity in Kitchener downtown area along King Street. The dashboard should include relevant data sets or data sets related to pedestrian volumes, compliance, conflicts, build me a map that lets me visualize the data set spatially, and this should include an interactive map and interactive data overlaid as needed. So that was all the direction I gave this AI, and obviously we can get very specific information to it, and now it's going to get to work on my ask. So it's looking through where are these locations, where is this specific district that I care about. It knows what data sets I'm looking for, and it's going to go and ask the network for all of those data sets to put together in a chart. Then the last step is actually building the code behind the chart in the dashboard. So not only are we simplifying the ability to put data sets together, we're actually changing the dynamic of how product development works or feature development works or how pieces come together that remove development from the equation when a traffic engineering team is actually trying to get to the bottom of a engineering project or a specific safety challenge in a particular neighborhood. So this allows you to customize dashboards, build focuses where you really need ongoing attention to data sets that you're going to be measuring over time, and allow you to customize those dashboards in a way you can actually execute them continuously. So we call this AI Studios as it allows us to build this in real time. It allows you to build this in real time. And the best part is I actually didn't cut any of this clip. What you're watching there on the right as Matteo was working on this was actually the real-time view of it happening. So it took my prompt, it took my requirements, it put it into the dashboard, and then built me a way to view it on a map. Where are the highest conflicts? Where is it over the pedestrian data over time? It interacted with the data in a few different ways and gave me a summary of my charts. So that was just a really quick example of how I can take data, build dashboards, and really visualize it in a unique way, specific to an area called King Street downtown that I could focus on. So let's go even further. So let's pick an intersection level dashboard. So I had Matteo help me even build prompts on another level. So let's take this data and ask Matteo to build us a map and actually put it spatially on a intersection overlay and let me interact with the map in my data points as well. So we saw the charts that Craig was producing allows us to go really deep into the data sets, but I can also ask Matteo to build me a map, overlay it on the map itself, and show me where the clusters are occurring, allow me to click on particular areas of the map, and let me interact with that video, let me interact with the near miss that's happening, or whatever data point I'm more interested in. This particular intersection had a fatality recently added. It's right outside of a university, so it's become a little bit of a focal point for the agency that's using this location. And spatially understanding where these near misses are happening have become a very valuable tool to them. Where are the hotspots? Where are the issues happening? So you can see on the right here, the chat basically broke down not just the data set that I want, but how I want to visualize it on a map. How do I want to heat map it? How do I want to represent the data sets and allow me to customize this view completely to my particular needs? And so you can see the clusters on the map here, and we can drill down into each one of them and see what happened and get a whole nother level of granularity. This is just scratching the surface of the possibilities of what you can do with maps and what you can do with AI generating tools on top of maps. So let's go one step further. This is a particular intersection. Let's go up to the network level. So at a network level, we can do the same thing. So let's zoom out a little bit and use a full map perspective and start overlaying some of the near miss data in a 3D map, conflict heat map over top of the entire city. So now I took that same data set and asked Mateo to build us a workspace and a map and a dashboard where I can now visualize the frequency of near misses, the hotspots in my city. Where do I want to focus my time? What is the worst intersection I should focus on? And allow me to manipulate the data in various different ways. So I asked Mateo to build some of the top charts for me, or the top toggles at the very beginning where we can then look at certain time frames, certain comparisons, certain attributes that we care about. We can filter to look at just the high and the critical, which we did here on the map, and really visualize the data sets together so that we can start overlaying them on top of each other. And this is actually relatively a basic example of how you can use a map and overlay the data set in a network view, and then start comparing volume to criticals and start normalizing the data in any way that you would like to normalize the data to relevant to your area so that you can then focus on the hotspots. The last piece that I will show, and what you can do with the data sets is actually start layering in other components. And I just took the last clip of this because didn't want that cycling constantly, but effectively I added one layer just to show an example here of schools. Like, so how do I actually correlate maybe something as simple as where are my pedestrian near misses in relation to schools? It's a very common challenge of safe school areas that we want to focus on. So how can I start correlating multiple data sets together, like where are my conflicts in relation to schools, and start focusing on those areas to make improvements. So there's a lot of different ways AI can actually accelerate our efforts. And you saw some examples here of how Mateo or Gen AI tools can actually start doing the integration work, start putting together the maps and the overlays, allowing you to jump from what I'm looking for in a data set to the actual analysis and skipping all that work in the middle. And we're starting to partner with groups like as powerful as Esri, all the way through to each one of the agencies that we're working with historical data sets to wrap those in APIs in a ways that we can interact with them. So I hope that gave you some really fun examples of how we could do that with Gen AI. That is about all I'll cover today. And if you want to know more, I'll be happy to talk about it later or answer any questions. In the meantime, I'm going to introduce our next speaker. I would like Chris Ryder to join me from the city of LA and talk a little bit about his experience with using safety data in the city. So I will stop there and let Chris join the conversation.
Hey, thank you, Brett. Hello, everybody. Just give me a moment to share my screen properly here. Excuse me. I was really happy to see the poll results earlier, and that a big chunk of our audience is local government, because that's what I'm here to represent, and want to talk a little bit about. Apologies, just need to bring up my notes that seem to have disappeared on me. There we go. All right, so great. I'm going to talk a little bit about the local perspective. And, when you work for a local government, you see all these great tools and you think about, like, well, how do we integrate these? They take time. And so what I've really worked on the last few years is kind of setting things up so that as better and better tools come into play, we're able to put them in. So I want to talk a little bit about the City of Los Angeles, DOT. We call ourselves LA DOT, our safety study, the past, the present, and the future of this. So, City of Los Angeles adopted a Vision Zero plan back in 2015. And the first step of taking that plan towards reality was the adoption of a high injury network. I think a lot of people are familiar with this. We did our first one in 2016 and we updated in 2017. And it was really simple, bare bones, only looked at killed and severe injury, KSI, and the data we had was already out of date, 2009 to 2013. For that 2017 update, actually. Data was even older for the first one in 2016. We really just looked at the killed and severe injuries, and then we weighted bicycle and pedestrian KSIs. We didn't look at contextual factors. We didn't look at any sub-severe crash data. And that ended up with 450 miles on the HIN. We came up with priority corridors, and we started a work plan based on this. We finally had the opportunity to fully update our methodology after COVID. We started to work on this in 2022, and it wasn't until middle of last year actually that we adopted it, but we went ahead and we called it the 2024 Vision Zero Safety Study. So this time we went ahead, we looked at all injury collisions. We weighted them based on Caltrans state has a local roadway safety manual in which they put a dollar value on each type of crash. We converted that amount into a weight. Fatal and severe weighted by a factor of 26. An evident injury was weighted by a factor of 2, and then any possible injury, what they call for LAPD complaint of pain, was weighted by 1x. But then there was an additional weight put if the collision involved a youth or a senior, or a bicyclist or a pedestrian, and those would aggregate on top of each other. So if it was a youth who was also on a bicycle when the crash occurred, it would get additional weight for both of those. And then we looked at some contextual factors, roadway and risk factors. And one of the goals was to shift away from weighting only your heaviest volume corridors. Because when you only look at crashes, you're going to go towards where there's a lot of crashes and not necessarily where you've got an outsized amount of crashes for the street type, or where you might have a street type that tends to have crashes, but just due to the chance of factors of whether or not LAPD was called, equity issues, whether the crashes resulted in severities, whether people drove away because there wasn't insurance, so nothing ended up getting reported. We looked at those contextual factors. And then we took the top 5% of scoring studies, made that our high injury network, which ended up with a total of 549 miles. This provides a really nice look at what the collision factors look like, how they're each weighted based on their size, and then some of those contextual factors. And that really plays into a lot of what we've been talking about is how do we take these contextual factors and make them more future-proof. So I'm going to get into that in a little bit. But one of the other things we did was we created modal HIN. So we separated out all the crashes that only impact bikes, only impacted peds. Motorcycle crashes, I don't know about your communities, but in LA, a lot of our fatals involve motorcycles, either solo crash or a motorcycle versus a pedestrian, often high speeds involved in those. So really focusing just on where motorcycle crashes are happening, we can identify whether there are different types of countermeasures for that. So there are some street segments that only appear on a mode-specific map. And that's really useful when we're looking at expanding pedestrian crossing opportunities, looking at certain types of grants. And then we also create a scoring for that. So in our original high injury network, we just cut off the top 20 for the first year. And then a later year, we did the top 50. And we focused our entire work plan on those top 50. Doing that, you're not always finding the conducive places where you can get work done. When you get access to tools like what Brent and Craig showed us, you might find opportunities that don't align with just that flat top X amount of your network. So we created a way to prioritize every segment on our high injury network and then every intersection and gave those a priority score. So we're able to identify synergies where we can say, hey, we've got an opportunity for a grant here. We've got political interest over here. Where does that rank amongst our 6,000 corridors, 4,000 intersections? Can we justify it as the top X% and not just say, oh, it's not in our top 50, it's not our work. And that's really been helpful. So now let's talk a little bit about gaps in our data, because I think that really goes towards what we're able to talk about when we look at new data. So one of the things in the safety study we tried to parse out was identifying why crashes are happening. Well, when you're looking at just crash data and you're not there, you're not able to get that much from the LAPD report unless you analyze each individual report and you read the narratives, something that, is a great idea for an LLM once we can kind of trust that that data would remain private. But just based off that top line, you're relying on the interpretation of an officer at the scene. And so these are the most common violation types by modes. And right away, you might see an issue, which is For vehicles, you're seeing that the number one crash type is an unsafe speed. Definitely makes sense. Motorcycles, number two, number one, the vehicle right away. Definitely makes sense. Pedestrian, you're seeing only 6% involving unsafe speed, but yet what we talk about a lot in the industry is that speed is directly correlated to the survivability of a crash for your vulnerable roadway users. And so what we discovered is that because this is the primary collision factor, most officers are going to write down whether it's a pedestrian violation, which means that the pedestrian, in their opinion, did something wrong, crossed against the red, crossed mid-block where they could call it jaywalking, or a pedestrian right away, which is that the vehicle did something wrong. In both of these instances, there may have also been speed as a factor, but it was not the primary factor. So in the data we have immediate access to, it's not counted. So that's a huge gap in our data in the standard way that we get data sources. You can see here on bicycle, you are also missing speed entirely. It didn't make the cut for the top 3 violation types by that mode. So immediately when we did this, we knew that we had a gap in our data, especially when you look down at all KSI. 16% of all severe and fatal injuries involve speed. Let me show you another one. So this was something interesting we did. We were able to map our crashes by time of year and then plot them against sunset. And you can see that there is a definite correlation between a higher incident of KSI collisions at a time of day right around sunset. It's sort of an obvious when you think about it, you can find it. That's why we knew to look for it. We were able to validate that. But then what's next? What is happening? Do we know that it is directly tied to the direction of travel? What are the potential countermeasures that can do this? That's still a gap. It's difficult to look at each of these crashes individually and find what you can do. But if you set up a near miss camera, if you set up a large language model to read all the crash reports aligning with these times of day, maybe you could find something else. Then there's also the whole question of how we don't know what we don't know. So obviously, it's a little easy to draw a connection between sunset and crashes, but what are similar things to this that we don't know to look for? And one of the great things that can happen when you integrate like machine learning into your data is you can find other similar correlations and determine whether there is a causation there or not. And then going back to our contextual factors, our data source for high-speed roadways was Wejo. Wejo no longer exists. So when we want to update this, what is our next source of high-speed data? Luckily, the way that we set it up, whenever we find the next great source of a high-speed roadway, we can plug that factor back into our algorithm to set up the high-injury network. If we find that there's a better way to describe high-speed roadways rather than like a yes or no, we can factor that in and provide the points in that way. Same with high pedestrian or bike activity. We took this data from Streetlight. They were getting a lot of their pedestrian and bike activity data from cell phone data, a source that's not as readily available. It's been highly replaced by connected vehicle data, but that's not going to get you a lot of pedestrian or bike activity data. So what are the other data sources that we could plug in here? Other roadway risk factors. One of the factors that we weren't able to do was number of lanes on the street because we just don't have a great data source for that. Now with machine learning, we'll be able to take aerial imagery and really get those counts in a lot clearer way than we were able to do even 2 or 3 years ago with the data that was available. And school and equity emphasis area, that's usually not going to change too much, but it's still something that you can look about. So let's talk about plugging the gaps. Volumes and speeds. Talked a little bit about that on the last slide. There are more and more reliable big data sources that come out. It's gone from a problem in the past where you had almost no big data sources for volumes, very few for speed, to where now you have so many of these sources, you have to do the work to figure out which one is the most reliable. Behaviors. So near miss analysis, I know Craig talked a little bit about that. We've used some of Craig's technology in the past to analyze this. Now being able to spread that out, make it permanent, we have ways to analyze this that we've never done before and plug it into our bigger models rather than just looking at spot locations where we already know that there's an issue. And similarly, as different companies are aggregating their harsh braking, harsh acceleration, and turning data and aggregating that, we can analyze those to find trends better than we ever could before. And one of the ways we derive those trends is generative AI, large language models, machine learning, identify trends like sunset that we talked about, which aren't immediately clear. And then another thing I'm really excited for is to identify the types of solutions that worked. When you have great data backing up where you've implemented countermeasures, whether they're signal improvements, whether they're quick builds, you can plug those in, look at all of your various sources of data from harsh braking to your crash data from PD. You can ask a model like Mateo or something similar, like, hey, where have our solutions that are in this map had the most impact? And can you identify things about the geography of that location or the types of crashes that preceded it that might give us a clue as to why that countermeasure was so effective there? And are there other places in the city that are similar? These are all questions that we've all had in our head as road safety engineers, transportation engineers. But it's always been a laborious manual process to get there. And I'm really excited that there are a lot of tools to get us closer to that. So let me turn off my screen share, and then I'd like to invite the previous presenters back on stage, and we can do some question and answers before we run out of time this morning.
Okay. Chris, thank you very much. And thanks to all of the speakers. You've just gotten sort of a high level picture of some remarkable tools, pretty amazing. Tools from Fireseed North and Myovision. So I hope you can ask questions of those. And Chris, that was great just to show how some of those tools are being used in an actual setting in local government. So thanks to the speakers. We do have a few questions. And I'm actually going to start out with one, and this is for Craig. Near misses. How do you define a near miss? Does the system itself pick out near misses for further analysis? And Chris, you might jump in too.
Yeah, so the definition of near miss centers on the possibility for impact forces that could cause an injury. So anytime someone dies in a traffic crash, it's because a force was applied to their body. That force came from the dissipation of kinetic energy that had to do with the angle, the speeds, the road user vulnerability. And there's just a certain force that if it's applied to your body, you're going to get seriously injured or die. Okay, those are biomechanical injury tolerance thresholds. And so when we measure the trajectories of road users, we're taking those kinetic variables, all the things that would determine how much force would be transferred to the human body, and we're putting that into the severity rating, all automatically, all by the computer. And so that's the severity side of the near miss. And then how close it is in spatial and temporal proximity tells you like how narrowly the crash was avoided. So how close was it to a crash? And if the crash happened, how big and bad would the forces have been? That is how the system says if there's going to be, it's a near miss or it was a benign event. Okay. And if it wasn't a near miss, what severity rating it was at. Yeah, it's very scientific, peer-reviewed, published methodology for that, Pete.
Okay. I could probably keep you on here for another 15 minutes, but in the interest of time, I won't. But I do have one other question. Are the camera systems at the intersections, are they tied in directly to the signalization? So you've got that time log, basically, you know what the traffic lights and pedestrian walk signals are doing?
Yeah, they're tied in. So the camera is tied into this computer that sits in the traffic control cabinet. The computer's sitting right beside the traffic signal controller. And there's a connection based on what controller protocol. Brent can talk more about that. But it's very important to know what the signal state was and how far progressed it was into that. So even if you have like 100 northbound versus westbound vehicle near misses per day, someone's running the red light, right? And if it's 90% westbound running the red light, that's the one where you have to increase the signal backplate size and
Hmm.
adjust the yellow timing interval or something like that. So you got to know when it's happening during the signal phase, and we're tied in there for sure. It also opens up possibilities to like make live adjustments, so we can um, uh, look at things that say like, okay, there's a pedestrian waiting to cross here, someone waiting to turn left. Before we give them green at the same time, maybe we dynamically actuate a leading pedestrian interval. So yeah, that connection to the signal control is very important.
Okay, great. Thanks. We do have one question from Ken, and he asked for agency to use AI agent, and I'm pretty sure Ken is referring to Mateo here. For the agency to use the AI agent, who would pay for the token cost? So I guess that's kind of a subscription cost issue for Brent.
Yeah, I can address that. Everybody is concerned with how much token cost it would be and how large these queries and development can go, especially in tools like AI Studios when you're really hammering the prompt level. So what we've done, I mean, a few different ways to solve for this, but what we did was we actually bundled the usage into a license cost for in the platform itself, basically allowing you to do unlimited usage of the tool sets or unlimited usage of the chats or the studios or the prompts, all bundled into a single cost that the vendor MyoVision or the platform itself will manage. It is often coupled alongside the production of the data, so whether it's purchased alongside the sensors or alongside the platform itself. We basically simplify that down so that it's not a per prompt based cost so that you don't have to worry about how much you're using on a daily basis, but we found a way to manage that for you so that it's a lot simpler, if that makes
Okay,
sense.
great. Well, Brent, as long as you're up on the podium here, another question for you. This from a guy like me who's been around for a long time. A lot of this stuff seems like magic, and some of the tools in Mateo. Although I guess that kind of applies to AI in general, but um, it looks really good. I'm wondering if you can cite, I'm going to say any shortcomings, either in how prompts are constructed and used by the system, or maybe you can put that in the context of improvements that you see in the near future for Mateo.
Sure. There's probably two perspectives or two ways to think about this question. One is uh, it's only as powerful as the data you give it. So if in one way, like if you're only looking at a problem from one perspective, you're only going to get that perspective in response. So if and what I mean by that is if say we did the near miss analysis application, but we didn't have connection to the controller, it's only going to give you the response based in the perspective of knowing that a near miss happened. It doesn't have the context of was it red or was it green. So it's limited in the access of data, and we try to honor the boundaries of data itself, the secure access, the structure of the platform in a way that you're not sharing data or you're not accessing things beyond your data set that you wanted to access, which means you have to build your data model at the base layer. Um, and that means you're connecting in APIs and you're making it as holistic as possible so that you get the most refined answer that it can produce. So that's one dimension that we have to consider is it considering all the perspectives. The second layer is validating what it actually says. I think the term that a lot of people know is the hallucinations. Is it making something up? Is it how do I know what it has told me is accurate? And this is where it's very important that we have the base layer applications, the science, the views that Craig was showing, or the raw data sets are also all accessible at the same time. So we're not necessarily replacing features or access to raw data or compiled insights. All of those need to be accessible in a way that when you ask for an answer through a chat tool, you can then go to the application, dig deep into that response, and validate what it said in a more holistic way, in an ease of access way. So you have to consider both sides of that when using Gen AI tools. Is it giving me an answer with a full perspective? And as a traffic engineer, you would know what you would do and how to answer that question. So you would validate it the same way you would be validating another traffic engineer. And then can I verify what it said through the data sources that it's providing through robust applications like the near miss analysis or the raw data sets themselves?
We do have a few more minutes, so attendees, please post any additional questions. I've got one or two more just to, I've got a little bit of time here. Another one for Brent. So I really liked what you showed about constructing a dashboard, actually showing the prompts and sort of progressively building that dashboard. If you're using those, you sort of built something that you like. Is it savable? Is it persistent?
Absolutely. That's kind of the idea of it actually is chats are chats in the sense of like you'll ask a question and you'll get an answer, but then you have to do that over and over again if you're going to be doing say like a monitoring task or a specific project. You don't want to be only in chat based. So the premise of the AI studios is to create a dashboard that you can save and share. So once you're happy with the way the dashboard is or the focus of the dashboard, say it's a pedestrian behavior project that you're doing in a downtown area, construct the dashboard in a way that you can get visibility and then you can share it with specific individuals. You can just update the date for timeframes. You can just change some of the filters. You basically can control the dashboard from there and use it in an iterative way. So you can continuously build on it, or you can just change the data sets or the timeframes that you're looking at, so that you kind of move out of the chat frame into the dashboard frame.
Okay. Yeah.
Yeah, exactly.
Okay. One other question. This really piqued my interest. Early on in your presentation, you talked about measuring the time it takes for a pedestrian to cross the intersection. Is that something that's obviously pretty important? It's impacted by a lot of variables. Is that something that's more or less automatic? How does the camera system or Mateo do that?
Yeah, so there is a part of the set of tools that we use are so there's the counts, which are obviously like pedestrians, bikes, trucks, cars. Then there is compliance, so like are they crossing against the signal? Are they crossing when they should? Then there's clearance, which is what you're asking about, is how long does it take to cross the road? And then there's conflicts, which is what Craig was talking a lot about. So in the clearance aspect, it's a almost a derivative of speed or whichever way you want to look at that in the sense of you have distance and you have time. So if you know how far the crosswalk is, so we draw out the crosswalks and you can just calculate how long did it take individuals to cross that crosswalk. And then you can measure that more holistically. We can do a couple different layers with that. So Craig mentioned one with using pedestrian detection for using for creating the LPI or actually having the LPI come up because there's pedestrians waiting. So that's one application of that. Another is just how long does it take? And then if they're still in the crosswalk when the light changes or it's about to change, extend the crosswalk time or extend the green phase so that you get more time to cross the road for some of the more vulnerable road users, effectively making the signal a little bit more dynamic around the
Yeah.
particular individuals at the location. So there's standards obviously of how long it should be as a minimum, but sometimes you need to create new maximums based on specific community needs.
Fantastic. Well, I got one more question, and then we'll close off the webinar here. This is for Chris. And Chris, great stuff. You're doing some good work there in LA.
Thank you.
One of your early slides mentioned the top 5 scoring for, and I wasn't sure exactly what that meant. Are you talking about scoring as a measure of priority for improvements, or what did you mean by that? And is there some sort of scoring methodology you're using?
Yeah, so we've got a couple different methodologies. One is how we just score segments of streets in general as to whether or not they meet the high injury network or not. Once we have everything that encompasses the high injury network, we're then doing an additional level of scoring within that. so that we've kind of got like a number one segment citywide, which just happens to be Florence Avenue, if you're familiar with LA at all. And then you've got your number two, your number three, your number four. And then out of all corridors that are scored citywide, we could also kind of identify what percentage it hits. So if we're told, for instance, hey, I want you to only work on things that are in the top 10% or the top 100. Any way you skin that, we've got the data out there to go and make sure we only work on that. The other place where it's really useful is we have 15 council districts, so the city's all carved up. Each of those council members has a lot of power. So when they come and say, hey, what are your highest priorities in my district? So even if it's maybe the 100th citywide, it's number one for them, we can let them know, hey, this is number one for you. It is something that we want to work on.
Mhm.
Even though if we looked at it from a citywide basis, it might not get up there. We do want to provide a little bit of equity to that end.
Okay. All right. Well, great webinar, everybody. I want to thank ConnectMe for organizing this. And of course, the speakers, Brent, Craig, and Chris, great job, you guys. But most importantly, all the attendees, thanks for taking time out of your day. You got, again, a high-level picture of these tools and methods. Please contact Brent with MyaVision, Craig, Fireseeds North, and Chris to learn how some of these tools are being applied. Again, thanks. Have a good rest of the day. You will receive a email with the recording link to the webinar. Thanks, everyone.